know why it would be.
I think it's Ken. We had that at the last conference as well.
Yeah, it happened last conference too.
Well,
yeah.
maybe, all right, I'll try earphones, see if it helps. Is it still buzzing?
Yes.
Uh-oh, but now I'm not hearing anything. Oh, no. Okay, yep, I'm hearing things too loud.
I think that's okay.
So is the buzzing gone now?
It's a little better, but just start anyway.
Okay. So if you had this question of woman is to man as king is to X, then the answer obviously is queen. But what's kind of maybe mysterious about this little snap program is how does it come up with queen here? So the first thing is that this block that I created called features of just returns 300 numbers for any of the 20,000 words it knows in any of 15 different languages. So what's kind of magic is that by taking the difference between woman and man, which you might think of as the essence of what it means to be a female, and add it to king, then you get queen again. And if I were to change king to father, then we get mother. And this little thing over here is meant to kind of illustrate the idea, which is that think of these words as being in this 300-dimensional space, and that the vectors are parallel if they have a similar kind of structure. So a different way to think about the exact same problem is that if you take the difference between king and man, which would kind of get the essence of what it means to be royal, and add it to a woman, then you get queen. And I think if I put here, maybe it'd be smart enough to come up with princess. Yeah. So you could do other kinds of tricks with this. You could find out what's the average between two words or whatever. But what I did for preparing for this talk is I added a new thing to it, which was, so here's the intuition behind it, which is if you take a vector, say the one between woman to man, and then the vector between king to queen to king, then the distances between them, Euclidean distance, should be relatively small if they're similar vectors. And in this case, we even get a little better, they're even closer if we say woman to man, but mother to father, that those are even more in parallel in some 300-dimensional space. So then I had the question of, well, since we know this, could we look for just discover new analogies by just coming up with any 4 of the 20,000 words? But the problem is that if we do that, and then for each of those 4 words, there's 6 different ways you could arrange them to make an analogy, we get whatever this number is, you know, trillions of possibilities. So what I did was I made a version of this that would search, in this case, for the 10 words that are nearest to woman, and then only show me the ones that have a somewhat decent score. 2 is still pretty bad. So it takes about 2 minutes to do this. So here's the, oops, that's, oh, I screwed up. Well, I'll run it again. Maybe. I accidentally changed it to, I'll show you while it's running. I thought, given that a lot of people are from Germany, that I would try it with German, but I don't think it did a very good job. Somebody who knows German better, but I looked at Google Translate a bit, and it came up with sort of pretty bizarre analogies. Maybe some of them are reasonable, but I think they're very strange. I tried it in Swedish, and it actually, the top 20 all made sense to me. And the English one, accidentally, I overrode it, but although maybe while it's doing that, I'll give you a sense of how it's computing this. So it's telling me how many things it has yet to explore. Oh, I should have, here, let me show you this before I, real quick. I'll just squeeze it down here. So it's showing that there's still 500 to explore, and these are the ones that it's found so far, but they're not sorted in any way, but they're ones that at least have a score of 200. So man is to girl, as husband is to wife, not so bad. I mean, these are, you'll see when it finally finishes that the answers are much better. So let me quickly, I've only got a minute left, maybe most. It basically comes up with, picks 4 words out of the 10 closest to whatever word I suggested, and then makes analogies for them. And the way it makes an analogy is just this distance between the differences between pairs of words, and it checks to see if one of them's in the wrong direction. But if either one of them is better than the threshold, then it gets added to the list, which we just saw. So hopefully by now we'll have a good, it's still almost done, but once it's done, it takes it a few seconds to sort it, but very soon we should be able to see these analogies. So it's just sort of playful, but I think there's something one could learn about linear algebra and about language in the process of playing with these things. And I would finally finish. So here's the 155 analogies it came up with. And the URL for the project is in the description of this talk. Also, I could put it in the chat right away. Okay, so I guess time for the next speaker. Oh, I have to select stop sharing. So hopefully people will play with it. I had fun with it. Somebody who knows German can maybe explain why it does such a bad job in German when it does a good job in English and Swedish.
I didn't find it particularly bad. So it said dog and tail and horse, which is another animal. So I think that was kind of okay.
Well, it gets into the area, but it's still not really the relationship between the pairs is kind of nowhere near as good as.
Thanks so much, Ken, for your talk. We really appreciate it. We're reminding you, we're going to save the questions till the end, and there is a forum in the chat for discussion on this. So Ken, if you'd like to see what questions people are asking, you can check out the Snap forum.
Right.
And we'll just pause here before we go to the next talk.
Okay, can you hear me?
Yes.
Yes, our next talk is Snap in Moodle. And I will let you take it away. Thank you.
And you can also see my screen.
Looks great, yes.
Okay, it's almost exactly 55 years ago now that there was a first exhibition on computer art. And the artist, by the way, did not understand or describe themselves as artists. They were mostly mathematicians, engineers, physicists, and so on. And this is not surprising because the computers of the time had to be programmed with Fortran, with Algol, or even in machine language in order to output the images of the first plotters. The range of skills required was therefore very technical in the early days. And what about today, when algorithmic art and generative art are the successors of computer art and can manifest themselves in multimedia, in animated and interactive installations, like in the example shown here. There are now even separate degree programs for media art, for digital art, generative art, and these training courses for media artists include a high proportion of basic IT knowledge and technical instructions to the corresponding tools. And in addition, we even have special programming environments specifically aimed at artists and designers. I just show the best known of them. So if you come from the artistic side, like me, you will face considerable barriers to entry. The tools mentioned are quite complex, which is of course also due to their great power. And they have, at least for me, a steep learning curve. So as an interim conclusion could therefore be, it takes a good knowledge of computer science and technology to create digital generative art. So fortunately, I didn't let myself be deterred from getting into computer art. And luckily with Snap, I found a great tool that is not only suitable for beginners, but also for ambitious projects. This is a photo of my last exhibition. So for anyone who, like me, started with a recoding and remixing of early computer art, very basic concepts are enough at first, like repetition, variables, or dealing with controlled chance. So here is such an example. Horst Bartnick is a German representative of concrete art. He worked intensively on relationships between simple geometric shapes, and his work with the computer allowed him the experimental implementation of the rules he defined. This example from 1985 combined circles with 2 lines each, and the result almost resembles a wall with world clocks. So the recoding of this example is actually very simple. Beside commands to move the turtle with motions, the concept of loops and variables are sufficient here. It made sense for me to turn this into an interactive installation. There the viewers should be able to influence the behavior of the systems themselves. So they should have the possibility of controlling the speed of the rotation of the pointers, and preferably separately for the 2 pointers you see. The controlling should be done via the horizontal and vertical movement of the mouse. And so the result should then look like this. Down left, the speed is 0 in both directions. Upwards, it increases for the first pointer. To the right, it increases for the second pointer. Unfortunately, the traditional animation method, that is a stop motion technique, is not suitable for this example. With the necessary sensor queries, the program would be bloated and the process would slow down considerably. So luckily I had learned something about the big ideas in computer science and programming in the BJC course. And from this I learned that it would be better to work with objects in this case. And in Snap I have the sprites and clones available for this. Without going into detail, it should only be mentioned here that the pointers are cloned and then given specific properties, but they can also react to global changes. So I have to admit, as an artist, I need to know quite a lot about programming concepts, and if only because if I want to know whether and how I can achieve something, then I have to know the possibilities and limits of my tools, and otherwise I easily overestimate or underestimate what is actually feasible. So I should, of course, be happy that there are initiatives to add an A to the STEM approach in school. In principle, this is a good approach. However, I get sometimes annoyed when I all too often find simple random graphics with lines, with dots, squares, or other geometric objects as concrete examples, and people already start talking about computer art when they put them randomly on the screen. For me, this requires an intensive examination of models and examples from art history. So the A in the STEAM, I think, needs carefully to be designed. Not an alternative, but an important addition, in my opinion, is therefore the integration of those big ideas of computer science and programming into the subject of art. And that can lead, I think, to exciting projects with often surprising results that demonstrate the power of these ideas in very meaningful applications. And at the same time, thus can be shown that the acquisition of solid computer science skills is indeed a worthwhile undertaking for artists. Okay, thank you.
Thank you so much for your talk, and I apologize for announcing the incorrect title. In just a moment, we'll have our next talk.
Okay. I tried to share my desktop. Stop me if there's any problem.
We can see it now.
Hello, everybody. This is about a Snap embedded in your own school environment. The main news is we have 4 official Moodle plugins to do it. And so, any Moodle administrator can install them with only one click. Beyond this, if you need it, the main project is a plugin builder, and so you can customize and even create your own plugin for your own Snap modification. Let's go to the plugin. Here I am a Snap teacher inside a Moodle course, and to request for a Snap project, I only have to create an assignment. Type a name and select a Snap submission with this checkbox. That's all. Release, isn't it? Let's look at some more features. The main content allows you to explain the request or even build your own learning resource with the Snap editor embedded. Copying this lab content and just this. And also you can upload other resources for your students, papers, presentations, libraries, and also if you want a Snap project. And then the project will be the template, the starting point of the activity. About submissions, maybe you want to request for other elements, comments, files with papers, recordings, and also you can request for other Snap projects. For example, here, a Snap for Arduino project. And here the same. If you want a template, you only have to upload at the Snap for Arduino project. For example, here the template will be the Snap Junior project. And we have a lot of Moodle features, feedbacks, workflows, grades, rubrics. But I want to point that if you use pair programming, you can assign this activity to those pairs teams. That's all. Look at the activity. I'm going to submissions. I will see there my students' projects. And I already see that my students are in pairs. Catalan, German, California pairs here. go now to the student's view. Here, I'm Joan student, and refreshing, I see the new activity, its contents, and starting. I see both projects with their starting point loaded. See, we have all Snap features and only disabled the cloud options. I can work on full screen if I need it, and just save when I want. I always see my projects and I can submit them when they are done, and I can edit them while they are still open. Now, refreshing the teacher view, I can see my students' work. It's still a draft, yes, but I can see it. I can set feedback if I want, and see it is a paired task. My most advanced team, Catalans, and my other lazy students. Oh wait, maybe it's a time zone issue. Of course, my pair Bernat sees the same, and he can update the project whenever he wants. No remote desktop needed. The project is both. And a roadmap. First, add a feedback plugin to allow teachers to send project corrections and ending proposals. Second, create a new cloud plugin, just embedding a cloud service like Berkeley Snap, and so keeping cloud features enabled. Because our main goal at the bottom of all this is to make bridges between the powerful idea of sharing, the community cloud, and the school needs sometimes more controlled environments. That's all, thank you.
Thanks so much for your talk.
Okay.
Our next talk is balancing project-based learning with building competencies.
Can you hear me all right?
Yes.
Oh, awesome. Thank you. So in this quick talk, I just wanted to share some of the experience I've had trying to make courses and student learning experiences that are very open and engaging, very constructivist. And specifically, I want to talk about this class. Oh, sorry, next slide. So this is my intro to programming class that I teach here in Beijing. And it's made up of mostly ninth grade students that have a wide variety of skills, coming in with different language skills, different math skills. So the first year that I came into it, I was really excited to do more open learning. I was coming from teaching middle school math and science, and I was definitely feeling very kind of tired of having students so worried about tests and grades and rote learning and memorization. And I was really excited to be moving into more opportunities to push students to explore. And an example of that from the first year of teaching, a student made this drawing pretty early on in the class after showing a few examples in Turtle Art, and students, a few students really excelled in this. And this drawing might look familiar because it's a Bob Ross painting, actually. The student went and found a good Bob Ross video and followed along and did the drawing in Turtle Art as they worked on it. And I had a lot of these like one-off successes, and it was really cool. It was really fun to see how students would explore and what they would try. But I was also finding that a lot of students were struggling with the unknown of it. They were really looking to feel more competent in the skills that we were practicing. And when I introduced something new, they wanted to have the time to practice it. And that was a pretty big challenge for me. And so then I started doing this like pendulum effect of more competence building, more of that. And then I'm like, well, but that's not what I want this course to be. I want it to be more students exploring the tools that they have. And so I came to think, to rethink it by looking at the time. And I realized, okay, I need to give an equal amount of time, if anything else, half to the curriculum and half to the students that are in the class and that should be doing the exploring. So I took all the lessons that were in the course and I thought of it as a bit of a math problem where I had a certain number of concepts that I wanted to reach in the lesson, and I had a certain amount of days to do it. And a number kept popping up in all the classes that I was teaching when I was trying to play around with this. And it was usually 6 days, and that was a nice number, mostly because it was even. So it meant that I could split that time and give 3 days of really focused lessons on that concept. It felt really tight when I first started doing it, but eventually I started to realize that it was just about the right amount of time, because then that would give 3 days for a project. And so I started building modules and projects that would go along with that. And I broke the rule of 3 very often. But 3 big lessons that I learned from it was that when I was planning the lessons, I was much more focused on what the concept was that I wanted to get across, and also how I was preparing students for the projects that I was going to get them to do. The other big takeaway is that the projects started to get more specific. They tend to be a little bit shorter than what I was doing previously. So I could scaffold them within those projects more focused. And the last one is that video that I took was actually a few months before COVID struck in China. So when we went to e-learning, following this structure really, really helped me and helped the students. And so that was a pretty big takeaway. So I hope you'll consider looking at a 3-lesson structure yourself in some of your planning.
Thank you so much for this talk. I definitely want to use some of that in my own. All right, our next talk is Geospatial Visualization of COVID cases in 2020.
I hope you can hear me, and you should see my screen just in a second. Okay, that's the wrong one. Let me try again. Anyway, I can show it in here. I start with a short video of the COVID cases in this year, and maybe you can just have a look at what you have done during the year yourself. Let me see. Here we go. So it all started in China, and before it jumped to Italy, and then we had the first cases in Europe, where we're still thinking that well, it's not a big problem for us.
Matthias, let me interrupt you. We're not seeing anything.
Oh, sorry. Let me see. Can I get this somewhere?
You might want to unshare and reshare. Then you can.
I'm just
again
lost.
select.
At the moment, I can just see a few. Having some trouble with Zoom here. I can just see the pictures of other people and nothing else. Why is that?
If you close the view.
Okay.
Yeah.
Oh, thanks. Let me try again, sorry. Can you see it now?
Well, we're seeing the same picture.
Map, yeah.
Do you see?
Now we're seeing your mouse, and we're seeing. Yes, we actually see something moving. Cool. Okay.
But can you see a world map?
Yes, we can see a world map, and we can see your mouse pointer.
Oh, okay. And you see a date at the left
yes.
corner. Okay,
yep.
Good. Okay, super. So this is the presentation. Let me move this out of the way. And now you should see that in China, there's some COVID cases are starting. Can you see that?
Yes.
Yeah.
Yes.
Okay, super. And then, as I said, it started in Italy basically, and then it jumped to the Americas. And that was about the time we went on lockdown in Switzerland. We were lucky that in the middle of June, we went back to school because cases went down quite a bit. And you can see now that some other countries are picking up. And we actually in school up to the summer holidays, and we still are, but at the moment, as you know, cases are increasing again all over the world. And basically what I wanted to do is to see whether you can do some data visualizations in Snap, whether this is possible. And as you can see, it works quite nicely. So we are now in September. We were still thinking that we are somehow okay, and then cases exploded all over Europe again. And as you will see, the situation is not all that good at the moment. So we are going into December, and 6th of December is the last day I actually had data from, because I put this presentation together about 1 week ago. Now, let's see what I'm trying to achieve. 2006, I was teaching students R, and it's quite difficult to teach 8th graders R. So I thought when I saw what was possible in Snap, maybe this could be a way to really do statistics and data visualizations with students. So I followed the typical 3 steps to get the data, transform it, and visualize it. And actually, it's quite simple in Snap, because you can just drag your data into Snap, and then you've got it in the form of a table. So that's really the easy part. And then you can transform the data. So you need some things like getting the labels, getting the data. I did this to get the column, which is interesting because I was tired of looking for the 3rd or 4th or the 5th column or whatever. You can group data according to certain criteria. And as in R, you can map over data and apply functions. Then there are some more advanced techniques like sorting, which is great because if you have to program your sort routine yourself, it's a pain. For each is very simple, and then the pipe functionality is also great because you can apply a number of steps to your data. Then you've got the visualization part on a map, which is basically 4 steps. You set up a central, the center of your map, you set the zoom level, so the whole world, or maybe a country, or even a city, or a street neighborhood. You can use the style, and then you just switch to that costume. It will display your map. And with a longitude and latitude blocks, you can just go to this place. And what I basically did was just pointing or drawing a point in different sizes on the map. So the problem is I have a quite fast computer, but it's not fast enough to do a live demonstration. So I took another idea from somebody, just saving the trails for each day, putting them into costume, and then you animate over all these costumes. And that's the way you get the animation you've seen at the beginning. Now, if you want to have a look at it, you find the link here, and also in the Snap forum, you can read my blog. And if you have time, go and look at the Media Computation Data Science course by Jagda and Jens. It's a really great course. I've learned a lot, and yeah, it's definitely worth it, and still open. Thanks a lot.
Thank you. Wow, what an impressive set of talks. We have about 6 minutes left for questions. So first of all, I think it would be great if everybody wants to use reactions to give a round of applause to the speakers. And I welcome you to enter your questions into the chat, or you can raise hands on the participants panel, or maybe speak up if you have a question.
I have a question.
Go ahead.
Joachim, how would you compare Snap to a lot of the other tools you've been using, processing and other things? Are there other things that we should include in Snap that you find that you love in other tools that, boy, if we just had like filled square, filled circle, filled arc, things like that? What are the other elements that we should make primitives for you and for other artists to be able to be very fluent in Snap that you've either had to build yourself, and boy, the other thing gives you for free, but we have to do, bend over backwards to make it work in Snap? Thank you for your work.
To be honest, I only worked for a while with processing and found it, for me, not very comfortable. And then I remembered my very early work with Logo in the 70s, and looking for a modern version, I discovered Snap. So it's very hard for me to say what from processing is really missing in Snap. I also did the last course of Jatka and Jens, and I learned a lot. And some may remember that I have published a book on coding art 2 years ago, and now I feel the obligation to rewrite half of the programs because I have learned things to make them more flexible, more interactive. So Snap is a really good, not only an entry, but you can do very serious art with that. And the normal way is not only in analyzing older things to recode them, but also when you want to make your own things. You have some ideas, you have to analyze what you will be doing. And sometimes I get to the limits, that's right. And sometimes I find new possibilities in Snap. Sometimes I'm not at the point I want to be. But fortunately, sometimes I can call Jens. He's just living 30 kilometers from me. And in many cases, we already found a solution, and I hope that will be also in the future. Today, I learned about cutout, so there are new possibilities. I can't say what's really missing compared to the other tools. They were too complex for me. And I think they are very complex for artists who have not a specific study in computer science or programming. One short remark. For me, many modern digital art is not so convincing. If you think of installations, they often are very fast. So you see colors exploding on the screen, and music in addition is always very heavy electrical music. So I'm now 70 years old, and I like music from the 60s, and I like slow movements. My animations should be very so designed so that you can see what's going on and not overwhelmed by all the cluttering on the screen.
Thank you.
I think Ken had a raised hand, but I'm not sure if it meant he wants to ask a question.
No, I wanted to answer. Brian had asked a question in the chat. He wrote, are the 300 magic numbers stored in your project or loaded from the net? So they actually are loaded from the net, because it'd be 20,000 times 300. And then if you did it for all 15 languages, it would just be an awful lot of memory. But it's be a very tiny program to make a copy as a snap list of lists and then save it in your project. So it wouldn't be hard to, if you didn't have a good network connection, to grab it. Also, we were careful to make a version of all this that works off a local web server so that you don't need the internet. And if there's 30 seconds, maybe I forgot to say anything about where these 300 numbers come from. And it was actually a project that Facebook did where they ran this machine learning program over billions of words. They took all of Wikipedia for each of these languages plus crawling the web. And the machine learning program's job was just to sort of figure out what a missing word is or what the next word in a sentence might be. But if you extract some numbers from the neural net, it's these numbers and they sort of magically capture something about each of these words. So that's what I wanted to explain.
There's one more question in the chat that hasn't been answered. It was from Nizar. I'm sorry if I said your name the wrong way. For the Moodle plugin, is it possible to have Snap in an embedded canvas instead of an embedded iframe? That's for Joan, I think. Let me check.
Yes, but I don't understand all the question. I'm sorry.
They want to know if instead of an iframe, you could embed an HTML5 canvas. But the answer is no.
It's not. It's not possible. The current plugin is an iframe in the same domain, and then the Snap or the Snap for Arduino is a distro inside that Moodle, and the next plugin it can be with the Berkeley URL with the new features of the API.
It looks like Akash posted another COVID visualization in the chat. I'm not seeing any other questions. So if you have one, you can speak up. I think we're into the break time now, though. So if anybody needs to go for a break, but if the speakers want to stay a couple more minutes, I think if anybody has more questions.
There's also, does everyone know where to go after the break? We're going to a new platform. So make sure everyone has the link for the platform that we're going to be visiting in 15 minutes or so. Just making sure everybody has
also, it seems that if you don't exit Zoom, then this other platform doesn't work very well.
Thank you, Michael, for sharing that link. Wonderful. Well, look, we're at the break. This concludes Snapshot, the formal presentation. I mean, I was the kind of bookend to this. Let's give a hand for all the presentations and all the chairs for all of their wonderful job. Thank you so much, everybody. Woo! Great, great, great. We'll see you all in OYE. Have a break and we'll see you all in OYE. Thanks again to all of the chairs and all the presentations. Outstanding. And these will be recorded, put on the YouTube channel. I can't wait to see them and watch them and share with my students. Great stuff. We almost got 80 people, by the way. So we had a great, great number, great turnout from all around the world. Here's what I want. Ready for this? I'm going to challenge all the audience who can hear me. Figure out a way to visualize on the map where we all are from. Automatically figure out some way, maybe we all can click, and maybe this is a shared document or NetsBloxy things where we have to click on something. We click where we're from and all the dots just start to populate. That would be really fun to think about maybe for the next conference. We can all just go run that program and click where we are, and all of a sudden you'll see how we're like all around the world. It'd be wonderful. Great to see you all. Have a break, take a stretch, get some food, and we'll see you back in OYE. Thanks, everybody. Woo!
Thank you. Bye, everyone.
Bye, everybody. See you there.